Alright, guys. So the thing is, the answer to that was very interesting. And you know what? Newton, when he discovered that, he felt actually that, whatever he has discovered, this entire science of calculus is actually, it's not a very great thing. It's actually very insignificant compared to the complexity of this universe. And he was looking at such great insights and things, and into such depths, that he felt this calculus is very little, very small in front of God's unlimited creation. The small bit of thing called calculus is very small, little. So he called it as pebble stones or calculus. That's it, guys. So our spirit for today is also the same thing. Differential calculus, it's not very hard. It's very small, simple thing, right? In front of the complicated universe and the complicated laws of this world, like. We know how complicated things are. Many people keep their status as complicated, and that's how life is always many a times. In comparison to that, this calculus is very little, guys. And don't get worked out, it'll be easy. Okay, so before we do that, we'll be doing this thing about binomial expression, just a little bit about that, because it's something also very interesting. So here's the thing about binomial expression, guys. So as you see here, I have this, we have already seen one part of it, which is, suppose I have 1 plus x whole square, right? We write it as 1 plus x square plus 2x. That is basically a square plus b square plus 2ab. Suppose I have 1 plus x whole cube. What do I write it as? A cube plus b cube plus 3a square into b plus 3ab square, right? Then suppose I have 1 plus x whole power 4. How do I get it? So for that we have a triangle, right? Have you heard of this triangle, guys? You have one here and you have one here, and you have hmm, two here and one here. Okay, and you have one here, and you have 2 plus 1 3 here, and 2 plus 1 3 here, and then another one here. And next one you have 1 here, 3 plus 1 4 here, 3 plus 3 6 here, 3 plus 1 4 here, and then 1 here. Okay, which means basically these are the terms of for this is for 1 plus x whole power 1. The coefficient of x will be 1 plus x. That's it here. Here you will have 1 plus 2x plus x square in increasing order, guys, like this. Here you have 1 plus 3x plus 3x square plus x cube, like that. Similarly here, 1 plus x whole power 4, you will have 1 plus 4x plus 6x square plus 4x cube plus x power 4, likewise. So this is called basically, the pyramid. This pyramid is called Pascal's triangle, guys. It's a famous thing, and we use this to find the coefficients. But is there a generic way of doing that for a 1 plus x whole power n? How do I state it for 1 plus x whole power n? How does the expansion unfold? Well, in 10th class CBSE, I think this was there, if I'm not wrong, right? Is it there in 10th class? Guys, put it up in your chat if you have seen it in your 10th, yes or no. Okay, 2 no's. Anybody? Yes? 3 no's. Okay, fine. Probably no then. It's completely new. Alright. If it's new, it's even more better. Um, so the expansion goes like this, guys. 1 plus x whole power n, you will have to write it as 1 plus nc1 into x plus nc2 x square, okay, plus nc3 x cube, plus so on up to, at last you will have nc n minus 1 x power n minus 1 plus x power n. Okay, this is the thing, guys. So what does this nc1, nc2, nc3, ncn minus 1 mean? Simple, guys. ncr can be expanded as n factorial divided by n minus r factorial into r factorial. Whoa, what are these new terms? So many new terms. Don't get frightened here. N factorial, it's just simple. N factorial means basically 1 into 2 into 3 into so on up till n. That's called n factorial. Okay, so all that which I have put in symbols here, I'll take a small example and do this and show you. That's it, guys. So as we have seen here, we got this expansion 1 plus 4x plus 6x square plus 4x cube plus x power 4. This thing here, I'm going to get it using this expansion and I'm going to show you guys. Okay. So as per the relation I have 1 plus x whole power 4, right? So here from the expansion of 1 plus x whole power n equals to 4. By the way, before I go there, just write this down, guys. Write this formula here. Write both the formula, this one and this one. Write this entire formula here quickly. Okay, so if you have written it down, let's go to the next part. I'm going to show you how we are going to derive that, guys. See, 1 plus x whole power 4, not derive it but application. How we will be applying that. That's what I'm going to show you. So as I've shown you, this expansion turns out to be 1 plus 4c1 into x plus 4c2 into x square plus 4c3 into x cube plus x power 4. So now I'm going to calculate what is 4c1. So as I've told you, 4c1 is supposed to be 4 factorial divided by 4 minus 1 factorial into 1 factorial. What will that be? 4 factorial is nothing but 1 into 2 into 3 into 4. Right? That's what the meaning of factorial means, as I've told you here. Right, guys? I've just now told you here n factorial is 1 into 2 into 3 so on up to n. Right? And NCR is n factorial divided by n minus r factorial into r factorial. Now that is what we have done here. Instead of n I substituted 4. Instead of r here I have substituted 1. And this is what it will expand as, right? So now I'm calculating each and every term. Take 4c1. For 4c1 it will be 4 factorial by 4 minus 1 factorial into 1 factorial. What will that be? Simply 1, 2, 3, 4 divided by 4 minus 1 factorial is 3 factorial, guys. Now 3 factorial will be 1 into 2 into 3, right? This thing. This thing here will be equal to 3, right? 3 factorial. Now similarly 1 factorial will be 1, guys, that's it, into 1. So see here 1, 2, 3 can be cancelled, 1, 2, 3. So I'll have here 4. Okay, good. Next, what about 4c2? Okay, let's do that as per the previous formula. I have 4 factorial divided by 4 minus 2 factorial into 2 factorial. Now how much that would be? 4 factorial is 1, 2, 3, 4 divided by 4 minus 2 is 2. 2 factorial will be 1 into 2. 2 factorial once again will be 1 into 2. Okay, so what would that be? 2 into 2 is 4. So take out 1, 2 here, 1, 2 here, and a 4 here. Right? So you'll have 2 into 3, that is 6. So 4c2 will be 6. Okay, guys. Next, let's look at 4c3. What will 4c3 be? 4 factorial divided by 4 minus 3 factorial into 3 factorial. Okay, what would that be? 1, 2, 3, 4 divided by 4 minus 3 factorial, that's just 1, guys, into 3 factorial. Now 3 factorial is 1, 2, 3. Now that would be, cancel out this 2, 3, 2, 3. That would be 4. Alright. So we have the same expansion, right? Is it not? That what I have already written down using the triangle. It would be 1 plus 4x plus 6x square plus 4x cube plus x power 4. This is what is the use of binomial expansion, guys. So for a generic x, I can write this using this particular relation. Alright. Right, as I've shown you, we can verify it using the triangle. Right, this triangle also we can verify. This is about binomial expansion, guys. That's it. More than this we won't do now. More than this you will look in your mathematics, because we need to leave something for them. Coming to the differential calculus, guys. So basically, what exactly is differential calculus? This is something very interesting for most people, and at the same time for most people who are new to that, it could be scaring. But either ways, it's very exciting to listen to this. The first time I heard it, I was like, wow, can such a thing exist? So I'll tell you first now, what is the whole thing about differential calculus? Basically what it means. It means a simple thing, guys. Finding the slope, that's it. It's about finding the slope. Okay. Well, it could be very simple. What is it? The entire differential calculus is just about slope, but then we already know what is a slope for a straight line, right? Is it not? Suppose I have a straight line y equals to mx plus c, as we have done the other day. For y equals to mx plus c, I know that what is the slope, guys? Yeah, slope is m, correct? M is my slope. And I've told you that m determines exactly how much curved this line could be, right? If m is more, obviously if I have a greater m, a line like this has a greater m, right? And if I have a line like another one like this, the m is even more, right? Out of these three, black, blue and red, red has got the greatest m, right? M of red is more than the slope of blue, right? Is more than the slope of black, obviously. So because you can see here, this is the theta for the black and this is the theta for the blue and this is the theta for the red. Obviously you can see, since m determines the slope, which can also be obtained as tan theta, guys. Okay, that is a new thing that I'm telling you now. Slope m can also be obtained as tan theta. How? See here, guys, very simple. Suppose you have a straight line like this. It has got an angle theta. Let's say this slope is y equals to 2x. Now think about this, guys. Let's say at this point the value of y, let's say, is y2, and consider here the value of y is y1. Let's say at this point it is x2 and this point is x1. Now as per the equation of slope, slope m can be given as delta y by delta x, because that in essence is slope, guys. Always the change in y divided by the change in x. Okay, that means what? Let's say this is delta y, okay, and this is delta x. Ratio of change in y by change in x, that is slope, guys. M equals to delta y by delta x. So this is something this is something which you might know surely already. Delta y by delta x, how does it turn to tan theta is the thing we are exploring now. So if you see here, delta y by delta x will be equal to y2 minus y1 divided by x2 minus x1. Naturally you see here y2 minus y1 will be this length, is it not guys? This length L, y2 minus y1, because y2 is this value here. This value is y2 and y1 is this value, which is maybe at this point let's call it x1 comma y1 as 0 comma 0. Okay, let's take x1 comma y1 as 0 comma 0. So therefore I will have a y2 as this length y and x2 as this length x. So as you can see, y2 by x2, that will be nothing but opposite by adjacent. What is opposite by adjacent guys? Opposite by adjacent is nothing but tan theta, is it not? Yeah, so this is an extra information I'm just linking here, but this has nothing to do with slope right now. But it's going to tell you and give you an information that yes, if slope increases, tan theta increases, which means basically theta increases, which means basically this line is going to get more and more tilted. That's when I say slope is more. So this should also correspond to the original definition of slope guys, delta y by delta x. You see, for a line that is more tilted, the change in y will be more guys. For a small change in x, you will have a more change in y. That means for this much change in x, small change in x, the change in y will be huge. If the line is so much tilted, you see the change in y will be so huge, this much. For a small change in x, you will get this much change in y. Is it not? Can you see that? Whereas if a line is more horizontal, for a small change in y, small change in x, the change in y will be only little, this much, right? So therefore theta in a way is directly linked to finding the slope guys. If theta is more, implies the slope will be more, because delta y, the change in y will be more. So why is this slope and why to know about how much change in y and all? Well guys, think about this. You have a curve like this straight, so you can say delta y by delta x very easily. So it's all basically telling you the incremental change in y for the incremental change in x. That means what? Many a times it happens that I have a curve, I don't have a straight line. Just think about this guys. Suppose um, y represents your profits. Okay, let's say x represents your expenditure. So what happens is, if you have a straight line, you can say, a lot of times when you see graphs, it's important to know how much will be the increments, what will be the change in y for change in x. That is precisely why the graphs are plotted. Forget about the all the mathematics behind everything. Just look at a small graph of a straight line here. If you have a straight line for profit and expenditure, so it's going to tell you that if my expenditure increases by a certain amount, say delta x, my profit is increasing at a fixed part, at a fixed ratio. I'm not saying it will increase exactly delta x, but it will increase at a fixed ratio here as well as at any other point, at any other x. Maybe here also, if I increase my expenditure by delta x, my profit would increase by the same amount. That's what a straight line signifies guys. A straight line is linear, stating its slope is same. So think about this guys other way. I'm an ocean engineer. I'll give you a better example with ocean. Okay, think about this. Suppose, let's say I plot you the depth of the ocean guys. Okay, this is the depth of ocean in, let's say, in feet versus the distance from the beach. Okay, so think of this as the beach. As you go into the beach, this is x. I am plotting you what will be the depth, the inside depth of the ocean. Okay, that means from the bottom of the ocean to the height. So if I plot you that graph, suppose that graph is linear, what does it signify guys? It signifies here, if you walk 1 meters, let's say for 1 meter change in x, okay, say this is 1 meter, the change in y is also 1 meter, let's say here. Okay, so this is true definitely here guys, which is at the shore. As you see always, ocean at the shore is little lesser steep, or basically less slope, which means what? For small change in x, the change in y is not significant, it is very less. But let's say you go 1 meter inside the ocean also, here 1 meter, there also will the change just be 1 meter? That means here also if I walk 1 meter, will the change in y, that means for change in x of 1 meter, x changed by 1 meter from here to here, right? For that, will I have a same change of 1 meter? Which is not the case, guys. In ocean, as you know, ocean is very steep. That means, the slope increases for the ocean. That means what? The ocean bottom will be like this, guys. This is the shore, right? Here if you walk 1 meter, the change might be only 1 meter, but then here if you go 1 meter, the change could be quite a lot, right? Here if you go 1 meter, the change could be quite a lot, right? Can you see that? That means what? Suppose you have a trench like this in between. Here you go, change is 1 meter in x. From here to here, the change is 1 meter. But what is the change in y? From here to here, the change in y is even more. Can you see that? That is what, the delta y will be quite more. So the steep increases. So usually oceans won't be like, the oceans won't be like this, guys. It won't be uniform sloped. Ocean slopes are usually very steep like this. Those of you in Chennai and all, you might be having experience. It will be quite steep. That means for small change, say 1 meter here, the change in y will be 5 meters. For 1 meter change here, probably the change in y could be even more, like 10 meters. Okay, that's what it means by slope. Okay, so another thing you will notice immediately is, you see, guys, as soon as I talk of greater slopes or varying slopes, the curve won't be a straight line. So the thing with a straight line, for a straight line, you will find the delta y by delta x is always same. Delta y, delta x. This ratio of delta y by delta x is same. Okay, for a straight line. That means basically for a change in x how much change in y you will have. But then think of a curve, as I've told you before, as I've shown you just now. Think of a curve like this. For a curve like this, the change is not same, guys. Okay, change here is different from change here, delta y by delta x, right? Therefore we come, we need to define this slope change, right? Change in slope, let's say this is y, this is x. We need to define this change in slope as a function of x, right? That means what? I need to tell how much will be the change in slope here, how much will be the change in slope here, how much will be the change in slope here, as I go, with x, how does that also change? So this change in slope, I'm calling it as a value, basically, basically the slope itself becomes a function now. Here the slope was constant, right? Same for a straight line of m, this is constant, right? So don't lose me now here, guys. Listen to me carefully. It's a simple thing, but then listen to this very carefully. Slope m is constant for a straight line, but then you take a curve like this, the slope m is no longer constant. Slope m is changing. It is different value here, it's different value here, it's different value here. So that as a function of x, to find that you need calculus, guys, and the slope is basically delta y by delta x, which you are defining, for the small part here. So you see this section of the curve, but if I consider a very small, you consider a very small segment here, it's like a straight line, is it not, guys? This part is like a straight line. So here I define my slope, delta y and delta x, in this small, in this small segment which appears almost like a straight line. Likewise, this I call as dy by dx. How small is how small is this delta x? This delta x is very, very small, guys. Okay, that means what? For this small change, the change in y, delta y, that means here you have a value y1, here you have y2, this is y1, y2, and this is x1 and this is x2. So this small change in y, right, y2 minus y1 divided by x2 minus x1, but then how small is delta x? Delta x is very very small, okay. That delta y by delta x, that's what is the slope there, but this delta x is very small, then it becomes dy by dx, okay. So for a small change in delta x, that means I'm calling it as limit delta x tends to 0, right, delta y by delta x, this is what is dy by dx, guys, okay, as simple as that. And this value of dy by dx is varying, okay, at different points. Here it will be a different value, here it will be a different value, here it will be a different value. Then I need a certain way of computing, right, is it not? That's what is differential calculus all about. So what I'm going to do, I'm basically computing all this. So I'm going to show you enough of entire talk, but I'm going to show you this thing. For a curve called x square, let's say I have y equals to x square, let's calculate what will be dy by dx, right? First thing, as I said, it will be a variable with x, right? Because it is not a straight line. Y equals to x square, not a straight line. Therefore, what will happen if it's not a straight line? The slope will vary, dy by dx will vary with x. So how it will vary? Let's find out. As I've told you, dy by dx is nothing but limit delta x tends to 0, delta y by delta x. So how will I calculate this? Limit delta x tends to 0. I am going to do delta y, which means what, guys? y2 minus y1 by x2 minus x1. Let's say x2 equals to x1 plus delta x, right? Basically x1 has got incremented by the small value delta x, which give you x2, right? That's what we are doing here. Like y equals to x square will be a graph like this, and let's say this is x1. Say you increase it by a small value delta x, right? This value here will be x2. So the difference is what is delta x here. Corresponding to that, what will be the difference in y value? So you will find here this is y1, y1 corresponds to x1 and y2 corresponds to x2, which is x1 plus delta x, right? So y1 will be equals to x1 square naturally, and y2 will be equals to x2 square. But what will be x2 square? x2 square is nothing but I'm substituting in place of x2 x1 plus delta x, because x2 is obtained by incrementing x1, right? x1 has been increased by a small value delta x. Therefore x1 plus delta x whole square, right? That's what will be equal to y2, is it not? So y2 minus y1, what will be delta y, guys? Delta y is y2 minus y1, which will be equal to basically x1 plus delta x whole square minus y1. What is y1, guys? y1 is x1 square, right? Minus x1 square divided by delta x. What is delta x? Delta x. That is what is delta y by delta x, guys. Simply put, right? Now let's find out how much that will be. Delta y by delta x, if I see, that will be equals to x1 square plus delta x whole square plus 2 into x1 into delta x minus x1 square divided by delta x. So x1 square and x1 square can be cancelled. I just expanded this, guys. x1 plus delta x whole square is nothing but a square plus b square plus 2ab, right? So x1 square plus delta x whole square plus 2 into x1 into delta x1, right? This one only, the same expansion, minus x1 square. So x1 square and x1 square gets cancelled. What do I have here? Delta x square plus 2x1 delta x divided by delta x. Now what is the important consideration I have? The important consideration is limit x delta x tends to 0. That means, why did I take that? See, because only when this interval delta x becomes very small, this part appears like a straight line, is it not, for this curve? Although it will be different value here, different value here, different value here, But when I take a very small value of delta x, then this portion of the curve appears like a straight line, so that I can define my slope as delta y by delta x, right? Because delta y by delta x is valid only for a straight line. So but when delta x tends to 0, that means the change in x, I can't keep delta x very huge, guys. If I keep very huge delta x as this much, this value, if I keep in this whole value from here to here, this is not a straight line, so I can't take the slope as delta y by delta x. It will give me wrong value, right? So the thing is, this condition is important, that delta x tends to 0. So what happens if by applying this condition? Simple, guys, just see here. If I substitute directly delta x equals to 0 here, delta x square will be 0 square plus 2x1 delta x, that will be 0, divided by delta x, which will be 0. So I'm getting 0 by 0 form, which is indeterminate. Therefore what I do is, I'm not saying it is exactly equal to 0, but I'm saying it tends to 0. Oh, what will change if you might think, what is this tending to 0? See, guys, this meaning tending to 0 means it's a very small value, like 0.000000001. It is not 0, but practically it is like 0. So what is the advantage of that? The advantage is this, guys. For 0 by 0 I can't cancel off, but then if it is close to 0 I can cancel off. So what I will do now is delta x square plus 2 into x1 into delta x divided by delta x. You see, this delta x, this delta x, this delta x, I'm going to cancel off. So then what will I get? I will get 2x1 plus delta x. That is my value of delta y by delta x at any given point, guys. At any given x1, this is the value. But what is the condition? The condition is limit delta x tends to 0. So just apply it. If you apply it, what do I get? This delta x is close to 0. So just ignore it now. See, even though I did not take 0 by 0 here, but then I can take it here because it's adding a very little value. 0.0001 is in addition. In addition, I can consider it's very little value, so I'll just drop it off. And then I will say that, dy by dx, what I'll say, guys, this is very important. If you just see delta y by delta x turned out to be 2x1 plus delta x. But then the condition is dy by dx is nothing but limit delta x tends to 0 delta y by delta x. Is it not? So this is an important thing, guys. This condition, delta x tends to 0. What will happen because of that? You will get a value dy by dx equals to, therefore, 2x1, because I'm dropping this off because it tends to 0, right? You will get 2x1 plus delta x, but this delta x tends to 0. Therefore, neglect it off. So you will get 2x1. What is so unique about this? This means that you got a relation, guys. Dy by dx is your slope, right? So you got a relation, the slope, how it will vary with x. That relation you got. How it will vary? Dy by dx will vary as twice of x. That means whatever slope you have for this curve, let's say this is 1. Here, whatever slope you have for this curve here, at 2, the slope will be twice, guys. Okay, that is very, very significant. That means the slope is going to increase. At 4, the slope will be 4 times. Okay, that means it's a very significant result that you got just now. You are getting a relation of dy by dx in terms of x. That means you are getting at each and every x what will be your slope, right? So for various functions, I already calculate this, I do this result and I tabulate, guys. That is what is my differential calculus table. Okay, so what it means, my differential calculus table will have various functions on this side and I will have df by dx on the other side, right? It's ready made, guys. You don't need to worry. So once I have that, I'm going to use it directly. Let's say I'll have your function as x square, here I'll have x cube, here I'll have x4, like, or log x, etc. Different functions, and here I'll have df by dx. So what are some functions like that? Let's just see some examples. So, you can see here the set of examples that we are discussing. First is this is a generic expression guys, but very important. So you see here, d by dx of x power n is given as n into x power n minus 1. This is a very important result here. So here we are not defining any fixed value for n. That means it can be x square, x cube, x power 4, x power 5, it can be even x power 2.5. Whatever it is, d by dx of x power n is always given as nx power n minus 1 guys. Okay, that is a very important result. So what we will do by that, as you see here, d by dx x power n given as n x power n minus 1. Suppose put n equals to 2 guys, what do you get? D by dx x square equals to n is 2 guys. So I'll have, in place of n, keep 2. 2 into x power n is 2 guys, so 2 minus 1, that will be 2x, right? Simple. Suppose n equals to 3, then what do I have? D by dx of x cube. What will that be? N is 3 guys, so keep n equals to 3 here. 3 into x power n minus 1 guys, so that is 3 minus 1, so that will be 3 into x square. So it's very simple. This is 2x guys. Just before we got the same thing, right? We have done the whole limit and everything and got the same answer, 2x, right? D by dx of x square, we got it as 2x. Is it not? Same thing we got it here directly. So likewise for any n, I can use even for 0.5. Okay, suppose n equals to 0.5, what do I get? D by dx of x power 0.5. What is x power 0.5? It's x power 1 by 2. That is basically d by dx of root x, I'm saying. What will that be? 0.5 into x power n minus 1, which is 0.5 minus 1. What will that be? 0.5 into x power minus 0.5. And what is power minus 0.5? 0.5 is nothing but 1 by 2. X power minus 0.5 is 1 by x power 0.5. That is basically 1 by 2 into root over x. That's it guys. So d by dx of x power 0.5 is given as 1 by 2 root x. And it's a predefined value guys. And this is going to tell you that basically your slope is going to reduce. As x increases, your slope reduces. When I say 1 by 2 root x, you see root x is in the denominator. That means as x increases, the slope is going to reduce for this function x power 0.5. Simple guys, just I'll plot you this and show you that the slope which is decreasing, this is an increasing slope guys. If I have a curve like this, right? For example, a curve like this, y equals to x square. This is an increasing slope guys. But similarly, what about y equals to x power 0.5? That curve would be something like this guys. Y equals to x power 0.5. That's a reducing slope. And that's what is highlighted here. The slope is reducing. I hope this thing becomes very clear here guys, that differential calculus is telling you how the slope varies with x and how you can find it, the method to find it. But we are not going to do all the derivations here. That's for the maths guys. The essential point of conclusion in all this is that very simple. We are just saying you that the slope is given by dy by dx, right? And we have some functions on one side whose dy by dx is already given, right? Whose slope or dy by dx is already given. It's tabulated, right? Here I have a function, here I have a table. So for this and this, I just know these values and I know what it means. The means of deriving these relations you will see later in your maths classes. For now, just take things for granted here, right? So these are few basic formulae guys. First thing is d by dx of x power n will be nx power n minus 1, right? And the second thing is differential of a constant is 0 guys. D by dx of a is a constant, so then the differential of a constant is 0, which means since a constant doesn't vary with x, is it not? So there is no differential to that. Delta y will be 0. Now d by dx of a into y, that means suppose I have a constant a multiplying y. What will happen to that guys? This constant just comes out of the differential guys. That means a comes outside and then I will have a into dy by dx. Okay. Similarly, suppose I have y as a function of y as given by two functions u and v. So y equals to u plus or minus